This next presentation is Dr. Dave DuBois. And Dr. DuBois is the state climatologist with New Mexico State University's Department of Plant and Environmental Sciences. As state climatologist, Dr. DuBois focuses on climate literacy through providing climate information and education to the public, speaking engagements, interviews, school demonstrations, social networking, and tours. Dr. DuBois is also the New Mexico Community Collaborative Rain, Hail, and Snow State Coordinator. That's COCO-RAS, and so he'll talk about that today. And Dr. DuBois chairs the State Drought Monitoring Work Group for the Drought Task Force. Dr. DuBois directs the New Mexico Climate Center and oversees a network of automated surface weather stations throughout the state that's called ZIAMET. So with that, thank you, Dr. DuBois. I will turn off my camera and take it away.
All right. Thank you, Marisa, for that great introduction. And so we're going to get started. So this talk is sort of three different themes that we'll talk about. I'm going to give you a briefing on the current drought status. Then I'm going to talk a bit about what we're looking at in terms of outlooks, longer term, and then more of the last part of the title, the planning and adapting part. So what are the impacts that we're seeing? What the kind of things are we planning for? Looking at the past to help guide and inform us in looking at, what kind of perspective should we be looking at in context of a climate that changes? The first slide I put together is something very interesting that we saw in the last few days. So this is the temperature over first 16 days of February, and it's we call it the temperature anomaly. So anomalies are basically the differences between averages. So how far off from average is the first 16 days of February? So as you can see, the Arctic air mass came down. Let me see if I can turn my little highlighter on so you can see what I'm looking at here. So my little laser pointer. So all this blue area is that Arctic air mass that came down from Canada. And so as you can see, it's even outside of the legend, more than 16 degrees below average for the first 16 days of February. And it's mainly the last few days. And so you can see the New Mexico was sort of on the edge of it, even though we had a bunch of below zero. If you go over here on the upper right, we had several days, and I just picked on Clayton since that was the furthest into New Mexico, where we had that air mass of -13 and -15 on February 14th and 15th. Not only that, it was not only that broke records for the low temperatures, but it also broke records for the high temperatures. So it was the coldest highs on both days, these 2 days here. So you can see this is a climate graph that we often use. The brown lines are the long-term averages for the low and high, and then the red are the extremes for the individual days, and then the blues for lows. As you can see, we dipped down, and it wasn't just a 1 or 2 day event. It was pretty much almost a week, and we're gradually rebounding from that. And it had actually a very similar trajectory and pattern than we saw in February of 2011. That one reached further, it had a little further western extent trajectory. And so and that one also occurred on a La Nina. So there's a few patterns that we see in when I was talking to the Weather Service this week, we were chatting about, La Ninas are typically warm and dry. However, we can get some of these really crazy Arctic air masses popping down from Canada on those type of years, and they're sort of what just happened. Those are the kind of things. Even the weather community is like, wow, that was amazing. Sorry about that. So Migo, looking at the temperatures. So this is the water year temperatures from October through January, and if you can see the coloring over on the right side is the ranking. So as you can see, most of the western U.S. from New Mexico all the way to California is even at the best, it's above normal, the top 33%. bunch of areas are in the much above normal, and a few areas, especially in California, were record warmest. So that's the temperatures. Here's the precipitation over the water year for since October through the end of January, and very similar picture in terms of the rankings, much below normal. That's the yellow colors. Very dry water year. That's and then a few areas, especially in southeast New Mexico and the Four Corners, where we got much below normal. It's the bottom 10%. So the picture is, we're sitting, and this is the reason why we're seeing this. The major part of this is we're in a La Nina phase of the El Nino Southern Oscillation, and so the La Ninas, like I said before, they typically are drier and warmer. Every La Nina is different, and the patterns of those they change from La Nina to La Nina. But this one is started off pretty typical. It's sort of transitioning back to a neutral phase right at this moment. Remember, La Ninas are cooler than average sea surface temperatures in the tropical Pacific, and it's starting to, the forecast as the latest ones are showing, it's starting to not as cool. It's starting to warm up a bit and maybe go into a neutral phase. So I just want to give you just a few, I think 5 different locations in New Mexico, the precipitation from the summer. And so it's the accumulated precipitation from July 1st to yesterday. And I'm going to go through several places, starting in Albuquerque. So you can see the smooth brown line is the long-term average in terms of accumulated precipitation. So from July 1st to February 17th, we've accumulated 3.55 inches. And you can see the green line is below the brown line, so we're in below average. So this difference here from at this point in time was 3.34 inches. So we're below average, more than 3 1/3 of an inch. And so in the last 30 days, we've only had just a little more than a half inch. Going a little further south, Los Lunas, very similar picture. We're about little over 3 inches behind right now since July 1st. And last 30 days, we had 0.69. And let me go a little further toward the southeast. Artesia, very dry for this area. However, we got a little uptick in precipitation this last storm. So nice amount of precipitation, 2.15 inches in this last storm. But as you can see, this really horizontal line. So it really hasn't rained appreciably enough. Basically, it was last time it really rained was back in August. Talk about a dry streak. So they're more than 4 inches, 4.65 inches below average, even after this 2-incher that came in here. And so in last year was pretty bad, and it had 9 inches last year. So even worse than this. Looking at a little further up north along the Colorado border, Dulce, they accumulated 9.8 inches. That's 3.31 inches below average. They had 10 inches last year. They had they're on a pretty good trajectory, but they had a very dry fall here, and they had some really long periods where they didn't have very much precipitation in September and early October. So there's a lot to catch up pretty much everywhere in the state. And if you look at, with the exception of a few isolated areas in the Northeast, but most all the state is in this below average. Farmington, this is where some of the areas where we've seen long-term, drought. Total precipitation since July, little over 3 inches, so 3 inches below average. So right now for this station, that's the driest on record. And then last year it was the 3rd driest on record. So very similar precipitation 2 years in a row. And just this last storm, they've accumulated 0.77 inches, but still there's a lot of deficit that they have to make up. As you can see, big differences between the long-term average, this brown line, and then the actuals here. That's that 3 inches right there. So a lot of impacts we're seeing from that. So I mean, look further up north. Go look at the snowpack. So this is actually the whole Rio Grande region. So if all the way from the headwaters in Colorado all the way down, all the way. So this is a lot of stations. So looking at the impacts, how much water is actually in this basin right at this moment. The black line is the current snow water equivalent. So that's the liquid amount of precipitation. And all these other these colors are the past. So the green line here is the median. So it's a long-term median. And then all the different line, this is the lowest and then the highest, and then we got different percentiles. So we're below the median right at the moment. We started out above, and then we missed out on a bunch of storms. So we've gotten this particular storm has added in a nice amount, but we're still in below average for the whole basin. Looking at a smaller basin, the San Juan up in the northwest, New Mexico into Colorado, very similar story, below the median. So we still have some time, however. So we, in terms of reaching the point where we have the same amount as the median, but we've been behind for several months, couple months now. So let's look at the hardest hit. As you go further south, the less snow we're seeing. So this is the Pecos. So this is on the more looking at the basin over on the east side of the Sangre de Cristos. Pecos, as you can see, it's below the 10th percentile here, so it's running around the eighth percentile. So here's same graph. Here's the median. So we still have a long way to go for in terms of adequate water for the Pecos basins. And very similar. I didn't show here, but the Hondo, very little water as well. So farther you get south into Mexico, the drier it is. Further north, the better. Still below average, but not as bad as the southern part of the state. I just want to show a couple graphs here. It was kind of interesting just to look at. These are NOAA puts these together, the Office for Water Prediction. At NOAA, they do a snow analysis for the entire country, and so the one on the right is yesterday's. So this is looking at the amount of snow water equivalent based off of observations and satellites. So it gives you a pretty good sense. And then on the left is last year. So same day last year compared. So just looking at, and you would say, oh, there's a lot of snow out there. We're looking at the one on the right. However, looks can be deceiving. So here's the amount using the observations. There's weather stations called the snow telemetry stations that measure the amount of snow water equivalent. There are weather stations that measure snowpack. And so basically the same graph, the same time period as the last slide, but it's more of a measure of the amount of moisture that's in the basins according to how we measure it from points. And you can see on the right is yesterday, and on the left is last year, same day. And you can compare the numbers. You just eyeball the numbers for a minute. The numbers on the left higher than the right. The closest probably is the Rio Chama. If you look at 89% of median last year, and right now it's sitting at 86%. So, and as you can see, as you go further south, the numbers get worse. Even from last year, we had like the San Francisco was above the median, but this year we're at 51%. And you can see the Rio Hondo, which is Sierra Blanca up in by Rio Doso, that's at 10% of the median right now. And last year it was 40%. So as you can see that we had actually more moisture last year on how we measure it. And even though there's still snowpack out there that hasn't melted, and that definitely is going to add in the soil moisture. Is going to definitely help. We need more of those at the higher elevation, because we use these high elevation to give us the surface water stream flows. So that's kind of how there's two different things we look at, not only the snow on the ground at the lower elevations, but we need to look at what's at the high elevations that provides us the recharge into our shallow groundwater, as well as the surface water flowing down our rivers. So I just want to give you that aspect when we look at maps. It's how do we interpret them, and what are we using the information for? So going further down, this is the current state of our reservoirs in the Rio Grande and Pecos. So you can see Elephant Butte, sitting up here, it's actually down here, but the numbers here, it's about 8% full, a little more than 8% right now. And then Caballo is 14%. And then along the Pecos, this line here, Sumner's about 51%, Brantley at 31, Avalon at 53. So that's where we are. And then I got two more basins to look at. So here over on the upper, we've got Heron 13, Elvado 11, Abiquiu at 38%. So where water is flowing through those, we can't store any water right at the moment. And then here we go up into the San Juan, into Colorado, into Colorado River, San Juan, Green River further north up. So in terms of where we are, Navajo Reservoir is at 62% full right now. And if you go into a larger reservoir on the Colorado, Lake Powell is at 39%. So still a lot of water. There's still a shortage of water here, you know, in terms of comparing up higher up into the basin you go, Flaming Gorge, 84%. So as you get further south, the more problem we're seeing in terms of drought, long-term drought. It's not just 1 year, but it's many years that we're seeing the impacts of this. So the other area I like to look at is soil moisture. So this is actually from NASA. We look at this in our drought monitoring work group. This is the 1 month change. So this is the current. If you look at the last 30 days and you compare that last 30 days with all the different 30 days of the past, it sort of gives us how much change do we see over the last 30 days. And so we're seeing a few areas that we've had snow, like in the Four Corners and the Chusca Mountains, and over here in Rio Arriba County in the southeast part, some good start on getting some recharge into the soil. However, most of the state is that yellow, that's that -% change, so it's drier. So if you look at back in a little further back, the 6 month change, so you can see a lot of parts of the state are drying out. You know, even with this snow, and you know, we see this on a higher elevation, some snow and some soil moisture recharge in here, but by and large, we're even with the snowpack, we still see some longer term drought. So this is the 6 month. If you look at the last 6 months and you compare it to the previous 6 months, it's dry. So it's going to take more than just a few snow events to bring up the soil moisture. So it's a long term. It's taken a while to occur. We've seen lots of impacts in terms of rangelands and forestry, and so it's going to take a while to build it back up again. We've seen lots of impacts. So I'm going to show this map. Basically, it's sort of the end of season from where we are right now. So on the right is the vegetation drought index. So that's at the beginning of October of last year, and then we compare it to 2019, the previous year. So this is kind of how the growing season ended. That's kind of what I want to show you. So you can see, you know, last year we had actually the year before, 2019, of summer 19, the monsoon of 2019 wasn't real hot either. We had a lot of dry areas, and then again we had in 20, the monsoon of 2020 was really dry as well. As you can see that we had a few areas where it's not as bad. It was more of pre-drought to moderate drought, but a few areas you can see, you know, this is a satellite and observation based model to look at vegetation stress from drought. Darker the red, the more stress, more drought impacts. So you can see few areas doing really very, very poor compared. So this is more of not just 1 year, this is several years in a row. And it's going to take more than just 1 year to really recoup things, in my opinion. And not only because we're below average in precipitation, because we have a really dry soil column, and a lot of things are tied to that. So here's our current map of the drought. This is updated every week. This is the U.S. Drought Monitor for New Mexico, and the last one was published on February 11th. And so you can see the U.S. Drought Monitor ranks the areas based off of a scale that goes from 1 to 4. 0, which is the yellow, is sort of pre-drought, and so as you can see, this map is built up over the summer and basically culminating in the fall, where we see these areas of D4, the exceptional drought, and it's actually the areas that are the dark, really dark red to the bright red. They are 82% of the state, and then compare that to, here's the statistics here. Here's our current 82% of New Mexico in area is covered in that D3 to D4. And if we go back to a year ago, we didn't have any, 0% of the state was in D3 and D4. So you can see how we've worsened over time the impacts of not only 1 year, but 2 years. And it's really has taken a toll. And so Marissa mentioned COCORAS. And so this is the background of this map is the U.S. Drought Monitor, but all these little dots, actually triangles, are what we call the condition monitoring. And those are COCORAS observers who basically we ask them to say, what does it look like in your backyard? What is your landscape's condition? Wherever you live, even if you live in an urban area, what does it look like compared to what you've seen long term? And so you rank them from severely wet all the way to severely dry. And then we ask people to submit. So this covers February 12th through 18th as of I downloaded this last night. So as you can see, the areas where they're high intensity drought, we see lots of reports. So we got lots of observers in Santa Fe County, Bernalillo, as well as Sandoval County, showing us, it's really bad, moderately to severely dry, as well as folks up along the Pecos telling us about this. So this is one of the things that COCORAS is a volunteer precipitation measurement program. It's volunteer, and it's basically citizen science. The main thing is measure precipitation, but we also we reach in and say, hey, what can you help us out with drought? So that's another use of that. Since you're already measuring precip, you're looking outside. So this is one of the products we have that is available if you're a member of COCORAS. So I just want to show one map of the outlook. So this is like a forecast, but they're not forecasts, but these are outlooks because they are looking at long term. So this one goes out through March, April, May, and on the left is the temperature outlook, and on the right is the precipitation outlook. And these are probabilities. When we do these outlooks, we don't give you the actual numbers in terms of what's the temperature going to look like or how much rainfall. It's more of the probability of either a below average or above average. So we do that for precipitation on the right. So it's showing you. So if you look at the Southwest here, that B, that's below average. So there's a 50% probability of seeing below average precipitation in most all of Arizona and New Mexico. And if you go out into further out, there's a 40% probability of below average for most of Texas, all the way, mainly going up into western Kansas, most of Colorado, Utah, southern Nevada, and southern California. So only areas where the Climate Prediction Center, these are the group who makes this, they're showing above average precipitation is in the Pacific Northwest and the upper Midwest here in the Great Lakes. So and if you go on the left side, this is the probabilities for above or below average temperatures. So you can see there's another A, which means in the numbers here, it's pretty high probability, 60% probability of seeing above average temperatures through the end of May, from March to May. So a big swath of warm temperatures. So even though we had this really cold outbreak, and it was really cold, it's going to come back to us. So basically the warm's going to come back. In terms of weather patterns, we're likely to see some more ridges, high pressure ridges out there that's going to move in and see more of the building of warmth, and then a lot more of the storm tracks will likely move further north, and as you can see here, below average temperatures here in the Pacific Northwest, and also the above average precipitation in the Pacific Northwest. That shows me that the models are tending to push the jet stream further north. The tracks are going to more clip the northern parts of the country rather than the south. So that's as of I download. This is as of the end of January. So these are updated once a month. We're going to get another update pretty soon. And it's probably going to reflect the dwindling of the La Nina impacts. So this may change a bit. I don't see it changing a whole lot, but this is likely going to stick around. So wherever drought is right now, it's going to stay, and a few areas are going to get worse. So if that's not real good news, but at least it's giving you a heads up through May. We don't know what the monsoon looks like. There's that, we call it a predictability barrier. We don't see, the models have a hard time transitioning between the wintertime storm tracks and the dynamic drivers for monsoon. It's more, we tend to look at statistics as opposed to these dynamical models. Dynamical models are basically will be used for weather forecasting on a day-to-day basis. And so it's more of, we don't really know what the monsoon is right at this moment. Okay, I want to transition more. That's more of the drought, what's going on. I want to transition more into the long term. What we seen in the past, and then where we think we're going. So I want to look at more of the climatology of things, because the last part we're more looking at the weather impacts of drought. We're seeing a lot of this is long term. So we're seeing in climate divisions, that's what these little regions are. There's 8 climate divisions in New Mexico. And I put together decadal trends, per decade. How are the temperatures changing? So I look at June, July, August, the summer, and I looked at it since 1970, and we're seeing all the areas in New Mexico are warming at about between a 0.5 to 0.8 degrees Fahrenheit increase over time per decade. So these numbers are per decade. So as you can multiply them out, that's kind of the trend that we're seeing, the warming over time. I know you guys have, I think the other talked about these. These are the projections looking at the historical compared to the next decade or so, a couple decades, 2010 through 39, and then mid-century and then late century. So these are sort of the worst case scenarios from the CMIP 5. That's the global models that we look at, and so it basically gives us an inkling of what could be a scenario, at different times along the scale, going all the way out to the end of the century. We don't know exactly what's going to happen because we don't know the status of everything. But this is a scenario that we plan for. That's if this happens, worst case, what are some of the implications for temperature. So for Albuquerque, here's our historical 57 by early century, by 2039, almost 60, mid-century, almost 63, end of century 66. So right now, I know you guys had another presentation on this. So this is sort of like in the West Texas, basically, the Albuquerque climate in terms of averages. So if we go to Las Cruces, further south, what do we compare to? Where we're basically similar to the Phoenix area in terms of Chandler, because right now we're at 62.6, and by the end of the century, that according to this scenario models, our average temperature, mean average annual temperature, will get up to about 71, which is right about the same as Chandler, Arizona. So that's our trend. If we are on this track of worst case, this is the RCP 8.5, and right now they're working on the next set of models for the next climate assessment for the world, but I don't expect any of these numbers to change appreciably. They're going to have more different scenarios in terms of emission scenarios because there's a lot of things going on. But basically, this is the trend that we're seeing. So this is I picked 2 different locations, Albuquerque and Las Cruces. This is past data. So this is nothing to do with climate models or anything. This is weather stations that we have. So this is the Albuquerque Sunport by the airport. The data since 1890s and going out, that basically is the amount of time between freezes. So if you look at the data, when is the fall frost versus the spring, and look at it every year, for 128 years, and that's just what each dot is the growing season defined that way. There's other ways to define growing season, but that's what this plot shows. You can see there's a lot of noise back and forth, but if you can go back, look at it, there is a trend going upwards. It's not as clear as Las Cruces, which is this map. So this is the weather station in Las Cruces. The same exact calculation, frost between the fall and spring. So we started off early in the century. The days between those, the growing season were somewhere around a little less than 200 days. And then as we go on in the 80s, we started to really see an increase. And right now we're somewhere around like 250, a little more than that, maybe 260. So that's the last 128 years of data. So this is weather station data. You can pick any weather station you want and plot these out. It's not that hard to do. If you want to know how to do this, let me know. Email me. I can show you, and I can just plot it out for you on Excel and just give it to you. You can see how your growing season has changed in various locations. So what are the implications? So that's past. I wanted to show you one of the examples of the future. This is the same scenario, the RCP 8.5. So this kind of worst case, looking at the change in freeze-free days. So this is how much is that going to increase? Looking at worst case all the way to the end of the century. So 2070 to 2100 with the RCP 8.5. That's the worst case climate scenario. So what would we be seeing in terms of freeze-free days increasing or decreasing? So right now we're seeing all increasing. So our growing season, according to the projections, are increasing in a few areas. So this is the coloring here. A few areas, a lot of them are in this 50 to 60, 70 more freeze-free days. So less freezing. So that's kind of the warming trend we're seeing, and that's probably the most. If you're take away anything in terms of climate change, the temperatures are the most striking thing that's going to drive a lot of the changes that we're seeing. And so, but so many things are dependent on temperature. Not just the water, but the ecosystems, livestock, animals, the food chain, all that, even our human health depends on the temperature. So that's that's the most sure thing that we're seeing, and we're already seeing that trend going up right now. So this is sort of we're already seeing these trends already. We saw these. Now it's more of seeing how the impacts are growing. So here are some of the bullets I put together in terms of recent. This is what we're seeing already in New Mexico. Statewide temperatures the last decade were the warmest of the century. The morning lows, it's not getting as cold on average in the mornings. So, and this is on top of the urban heat island, which I'll mention in a few minutes. Longer growing season, freezing level is a little higher. You have to go a little higher in elevation to find freezing. And then we're seeing things like dust storms are changing things over time. Not every time. I mean, those are usually high wind events, but we're seeing those. So I want to talk a little bit about we're talking about trees. Wildfires are going to be one of the things that we're concerned about. Warmer, drier springs and summer conditions, earlier snow melt, looking at summer fuel moisture, longer fire seasons, increased fire frequency and extent, and looking at the intensities. So I got this from the National Climate Assessment, showing the number of wildfires. Large wildfires have been trending upwards. There's a lot of variability, but if you look at it on a long-term scale from the 80s to the present, we're seeing these trends go up, except for some area in the Mediterranean, California was trending down. But for here we are in Arizona, New Mexico mountains, this trend is going upwards. And I thought I would bring this out. This is a nice tool, and I put the URL on the bottom right. And if anybody wants these slides, just let me know. I can email them to you. This is a tool, it's a web tool I was looking at last night and say, oh, this is great. And it basically shows you the wildland urban interface. And it's a Google map that you can zoom in that shows you where you are in terms of are you considered in a interface, more of the outskirts, but or the intermix, you're right in that WUI, the wildland urban interface, in terms of risk. And we know we benefit from our trees, but there's also a risk that's associated with it that in terms of climate, we have to consider the benefits and risks when we're in the midst of things with a changing climate. And so this is a really good tool to kind of help us as a society kind of, okay, where are we? Let's take a satellite view and look at things, and where are we? And so I think this is a great tool to kind of think about the context you're in, because we know we've got all the major fires in New Mexico have occurred in the 2000s. So these are, I just went on the MNERD website and grabbed all the large fires and I just ranked them, and they were all in the 2000s, going all the way from, and these are everything more than 50,000 fires, all the way to the 2011 up north, the Last Chance, all the way down to the Whitewater Baldy, which was in the record area back in 2012. So we're seeing this transition to really large, impactful fires. Where we see high winds, lots of very warm temperatures. Our droughts are warmer now than they used to be. So like the 50 droughts have been probably drier in terms of the number of days without rain, but our droughts now, our temperatures are much higher, and that has actually accelerated some of the things that increase the wildfire risk. In terms of the heat and water stress vegetation, pests and pathogens, take a toll when you get multiple years. And then also the weather plays a part, chances for dry lightning and things getting out of control very quickly. I show a little bit about the drought monitor. So this is just a kind of a review of it's basically percentiles that we rank things like precipitation and soil moisture. And so where have some of the big fires have occurred in terms of the state's drought monitor? So these are all since 2000, and I put some of the large fires on there in black. And so as you can see, over the last 20 years or so, the large fires have occurred when we had big parts of the state. So that the colors are the percent area of each of those drought monitors. So you can see Las Conchas, majority of the state was in D3 and D4. Same with Little Bear, Ponil over here on the right. So you can see, there's obviously a correlation, very dry, and we get the large fires here. And so I just wanted to kind of review real quickly, just one of those, like a lot of us experienced Las Conchas fire back in 2011, 126,000 acres. And I just want to focus in on the conditions that were preceding that fire, looking at the impact. So what was it riding on top of in terms of the climate? And so the veg dry, I showed the map like this. Remember, I had the two graphs, the 2020 and then the 19. This is what it looked like in 2011. So you can see that drought stress was in much of New Mexico, and is even, so remember, this was a 29 and 10 was an El Nino, and then we transitioned right into a La Nina, the 2011-12. So as you can see, that further south you go in New Mexico, the drier it got. And these are the climate graphs, maps. So on the left is the precipitation ranking. So that red is record driest, and on the right side, the temperatures, record warmest, the whole entire state. So that was the environment that these fires got started in. And here's these are our impacts. When we see the impacts to the our where we live, water quality, air quality, ecosystem, agricultural losses, infrastructure, toward many other areas. These are some of the impacts we have to live with. And I just want to show you another tool that I came across. This is the Forest Health. It's from MNERD. These are updated to show that the areas based off of surveys where problems are in the forest. So this is also a zoomable map. It's just showing, and it's colored by the different disease types. And so if you click on those, it'll tell you that what kind of pest or pathogen, either a fungus or a beetle or some kind of other insect, kind of just to show you, combining it with the WUI maps with the Forest Health, and kind of the sense of thinking about what are the risks and how do we manage our living spaces. We love trees, we need them. However, there's risk that we have to look at. So and my purpose is to show you that the climatological perspective of things, where we are and where we sit in terms of different years have more risk than others. So I just want to show you the impacts, just to look at put in perspective the precipitation versus temperature. So this is a graph that shows you for the really warm over here and then really dry on here. So the average precipitation in climate division 2, which is northern mountains. And if it's over here on the bottom right, that's the worst case. So good is up here. So our wettest year was 1941. And some of these years over here, like 2017, 12, and 20 last year, was sort of some of our driest. Our driest was 1956. Remember I said that they were drier, the droughts are drier back then, but our droughts now are warmer. So if you move along this scale, they were about 47 degrees, but now we're in the 49 degrees. So we haven't it's like 2 degrees, but that's a huge amount. Even 1 degree average temperature, that's a lot of change. And so as you can see, we were 2 degrees warmer in that 2012, and this annual average temperature in 2020. So we're very dry. The average was just a little above 10. So this is kind of our very concerning part of the graph here. There's less of that, more to scatter into these wetter or kind of average. But when we get into these, even if it's wetter than average, like 2017, it's still a lot of concern for us in terms of how we manage and how much water is used. And so I just wanted to summarize the wildfire thing, and this is from a 2016 paper, Proceedings of the National Academy of Sciences, says the impacts of climate change have increased the odds of more extreme events and conditions that cause large fires. So climate change is already affecting fires in New Mexico and across the West. So every year more studies are coming to this conclusion. And this is a quote from the paper, is anthropogenic climate change accounts for about 55% of observed increases in fuel aridity from the 1979 to 2015 across the Western U.S. forests. And then another quote was, human-caused climate change contributed to an additional 4.2 million hectares of forest fire area during the 1984 to 2015 period, nearly doubling the forest fire area expected in its absence. So these are some of the conclusions. Other papers have come to similar conclusions to look at things. So the last few minutes, I want to talk about other things that impact us. So the wildfires, obviously, heat waves, allergens, droughts. There's a lot of impacts to that for us. Wildfire smoke is another big one. So what we want to do is, what are some of the mitigation that we can do in terms of heat and looking at it. So I want to just address one thing. It's looking at the urban heat island. So what is that? So basically, it's our neighborhoods are hotter than our surroundings due to the stuff that we put, all the buildings, parking lots, driveways, things like that, concrete. So what are we seeing? So this is Las Cruces. I don't have a map of Albuquerque, but I just picked this one. This was a nighttime Landsat flyover. It was like 11 p.m. back in, it's a few years ago, but it basically shows the same impact as it would probably today. Looking at the nighttime temperatures in the wintertime, where are the things that radiate the heat out? And you guys probably had talks about this in terms of the biomass is cooler than the rocks and the concrete. You can really see that. You can see the roads, the road networks, and some of the big parking lots, and pop right out very quickly. And this is 11 p.m. And so what are things that we can do? And some of the things that come up the top over here are the interventions. So shade, we need shade, trees, cool roofs, cool surfaces, and then of course we need our living quarters where we, especially during COVID, we can't go out a lot, so we need to cool our indoor areas. And then what are the impediments? Well, a lot of people have inadequate cooling, and some of them by choice or not. So what are some of the things? So what we did, and I just want to show you kind of a intervention, is the city of Las Cruces and El Paso. We did a mapping campaign, and this was outside. We got funding from another organization to look at patterns of urban heat in the community. And actually, Albuquerque, I think, is going to be doing this coming summer. So keep look out for it. And this is where the campaigns were in 2020. So these, all the little circles, were the places that were mapped in the summer of 2020. And so we collaborated with the city of El Paso, with the city of Las Cruces, and we did a heat mapping study. And the bottom here are the funding agencies that provided the funds and resources. So we picked a hot day, July 10th. We had a bunch of volunteers and some funding and help from the Green Chamber. We had 5 car routes, 2 bicyclists, and we had 3 different times we mapped. We put little temperature sensors on their cars and bikes, and we drove around from 6 a.m. to 7 a.m., 3 to 4, and 7 to 8. And bottom line, here's kind of the route that we took in Las Cruces, and there's some couple of our volunteers drove a car or a bicycle. And so this is our afternoon. Remember, there's 3 of these. I'm just going to show you one. This is our afternoon mapping. And basically what it did, we had the thermometer outside the car, and it took a measurement every second. And then we looked at it and mapped it on a geographic information system. So this day we had a high of 106 Fahrenheit, and we had a heat index of 111 in some of the areas, especially over here in the urban, the more dense urban part of Las Cruces. And some of those areas didn't have any. There's lack of trees in those areas, lack of cooling, and so it's very, very high. Whereas some of the areas are more spaced out, and there's actually a golf course right here, but there's also areas where there's a lot of concrete. And so I also did a infrared camera survey of different areas to look at during the hottest part of that day, and just showing you some examples with the camera takes both a visible and a far infrared to compare what does it look like, looking at shade, the sidewalks, the air temperature. This is just the surface temperatures, but it gives you a real sense of the variability of how much shade provides in terms of the relief. And looking at the temperatures of the ground over on the bottom right is 150 degrees Fahrenheit. That's the surface temperature. I mean, if you were to walk on it, it'd be really hot. But looking at the grass is a little over 100, and some of them are even cooler in the 90s. So there's a lot of benefits of shade. It's kind of obvious, but we need to demonstrate that and show people without these shade areas, it's providing that evapotranspiration, cooling, as well as the shade. This is part of what we're trying to do. So the last thing I want to show is, and I mentioned a couple times, and Marisa mentioned it, is how you can get involved. Is one of the things that we do is we map precipitation, and we also map drought impacts. But the core of this volunteer effort is measuring rain. So this is the Community Collaborative Rain, Hail, and Snow Network. That's what COCORA stands for. And it's basically is folks getting together, just like you and me, anybody, and we take a measurement every day, usually in the morning. So these are all the dots. All the dots in the mix are all volunteers. They have a gauge like this in their front or backyard. Mine's in my front yard, and they look at it every day and they measure how much rain or snow has fallen. And so we've been blessed with a lot of measurements, but there's a few areas we really need more. I mean, it's actually good that we get a lot in the urban areas, but if you live outside of the area, that we really treasure that, because there's big areas, expanses where we don't see very many measurements out there. And this is a lot of our climate maps that we use across the country. They use these data to fill in the gaps of some of our nationwide maps. So it's not just a fun. I mean, it is a fun project, but it's not just for the scientists. It's actually used on a routine basis to look at the climate of the U.S. So you would be providing a service as a volunteer to help build a climate legacy for people 50 years from now be looking at this data. And so it's an honor to be part of this, because of that. You get to actually become part of the legacy of providing climate information. So it's a fun and exciting thing, especially when it does rain or snow. You get to say, oh yeah, I measured 0.3 inches. What did you measure? Or I had 11 inches of snow, and you actually can put your data, and it goes into a map, and you can click on it. So there's my data right there. So that's kind of the benefit as an individual you get. It's exciting, but it's also, for us, the National Weather Service uses this on a daily basis. They have actually one of their products goes through all the COCORA's observations, and they report back, and they actually, on their weekly weather briefing, they have a specific map that we look at that is just COCORA's reports, and they use it on on top of their radar on all the other maps that they show. So this is it brings up the importance of this this network. So I encourage you to go to that website, and it's basically kokoraz.org. You can put www or not, www.kokoraz.org, or just go kokoraz.org. And on the upper right, there's a join, and the gauge is I think around $40. It's going up, I guess, with the price of plastic and shipping, but it's a really good opportunity for you to get involved if you're not already involved. If you're already involved, I thank you, appreciate for all your hard work and looking at the gauge every day, and thank you. But if you have somebody who you would think wants to join, let them know about it. And we have occasionally we'll have with COVID-19, we'll have Zoom meetings to encourage folks, and we're probably going to come up with a 2020 weather overview with the Weather Service office in Albuquerque and Santa Teresa. So we're going to be doing that pretty soon. So stay tuned. And I think that was about all I wanted to talk about is basically the put in context the climate, where we are, and then where do we sit in terms of what do we manage, what are we looking at in terms of temperatures. So what kind of, get us in thinking about how we should be managing our area that we have, and letting people know about it. And because we don't want to see fires like this one. This was back in a few years ago in the Pecos, a big wildfire when I was living in Santa Fe. And this is sort of we don't want to see, but fires are going to always happen, and it's just a matter of how we deal with them and how we become more adapting to things like this and become more resilient in terms of how do we protect ourselves and our infrastructure. So I appreciate it. I guess we can do questions now. Thank you.
Yeah, thanks so much, Dr. DuBois. So we do have some great questions for you, and I'll start with this upvoted one. Excuse me. This is from Joseph. The question is there any data on how much climate change is affecting tree canopies in New Mexico or in Albuquerque specifically?
Great question. How is climate change impacting tree canopies? I don't have any specific information to give you, but I'm sure there are information out there. I think we could follow up with that. There are a few groups out there who would be probably we give you a sense of that. I mean, I deal mainly, I work with a lot of groups, and I usually try to partner with them, especially like USGS. I know it's a few of the guys who work in the Rocky Mountain Research Lab, I think that's what it's called, and I would probably refer that question to them, because I don't want to make up an answer, but it's sort of I imagine there are definitely impacts, but yeah. Thank you.
I have kind of a similar response. I'm sure people are looking into that. I don't know exactly who. I imagine UNM biology and NMSU biology department. There's some tree research going on, and then people are looking at the canopy coverage and how much that has changed over time, and it's not. So I'm sure there are people working on it, but I think it looks like that's a popular question. So if you're interested on that, I'd like to look into that. Maybe that could be something I make as one of my columns. And so I'd be happy to share that. Okay, next question. This is from Robert. Any predictions on how this would affect insect populations and their impact?
Oh, yeah. As part of our drought task force, we have this thing called a drought monitoring work group. We meet monthly. And we've got a member from EMNR, the Energy Minerals Natural Resource Division, the forestry, and we get updates from them on the forest health, as well as the number of acres and number of wildfires from natural and human caused. And so we get regular updates on forest health, and a lot of times we get the maps, and they do a annual survey. And I forget the guy's name now. It was top of my head just a second ago, but I forgot. Formby, I think, with EMNR. I think that's his name.
John Formby.
Formby, yeah.
been in our
Yeah.
conference.
So
Yeah.
I don't know. Is he on this meeting or?
Let me check. I don't
He
see
would
him on
probably
right
be the
now.
one that I would consult.
Yeah, thank
But
you.
there are definite, they map out the different insects from bark beetles to these little worms and things. I'm not an entomologist in that area, but there's some years or more in other areas. And that was one of those maps I showed. If you really want to go and find out what the latest, I mean, and they're usually 2019 is available. I'm sure 2020 will be available eventually soon. But those are, and then I would consult with the forestry division or the Forest Service.
Thank you. Yeah, and it reminds me of a presentation I saw last week with the Native Plant Society in Las Cruces. They had a speaker, Scott Fehrenberg with NMSU Biology, and he was talking about tree problems and fire, and he was describing that we are concerned about fire, obviously, and it is something to be concerned about, and that the drought impact on fire, we can see that correlation, but what sometimes we don't think about is that how the drought affects the trees and their ability to flow sap to a wound site. So boring insects are likely to have a bigger impact on drought-stricken trees, and there's all those tie-ins with those the primary problem being drought, and then tons of secondary issues. So thank you. I like that question, and that also can help us lead into having speakers for next year. Okay, so the next question is from Jimmy. There's much talk about climate-ready trees for a warmer climate, but it's my understanding that we will experience more frequent and extended polar air masses like last week and in 2011. So is this correct?
Really good question. Yeah, I mean, there's several things that, and this would be a really good group discussion. So in terms of, you've got these short-term events, but the average is going up. So in terms of the growth of the tree and maybe, if it's I'm thinking in terms of, the survivability, if it's in a stage where it's more vulnerable, it may be, that it may be higher stress, but if it's an older tree that it has more capability to rebound from really cold snaps, I think in my opinion, I think we need to really consider that warming trend over time, because it's going to change the dynamics of the amount of water it needs, as well as the temperatures. And it's more that all the year growth compared to all, even if we do get one or two of these every year, how much of an impact is that going to have on the whole 365 days of the year? I don't know. I'm not a tree person, but it's sort of, those are competing things you got to think about in terms of the freeze dates are going to get changing. They're moving out in terms of their so I don't know, maybe Marisa, that you could probably add to that too.
Yeah. And a logistical note, Dave, if you'll stop sharing your screen, I guess some people are doing on their phones, and so
There you go.
will be bigger. Okay, thank you. And also, on a side note, I loved your slides. Can we have your permission to post them with your presentation so people have access to those?
Absolutely. Yeah, go ahead.
Thank you. Okay, so along the lines of, and that's one thing about this Climate Ready Trees project, and anytime that we are trying to describe it, I think there's so many different facets, it's hard to fit it all in and make sure you say everything. But Jimmy's question brings up this point that Climate Ready Trees list is really good for when we're thinking about planting trees that are going to still be thriving in 50 or 80 years. But there's also the short-term trees, and there are short-lived trees, and that's okay to plant things that are only going to last a couple years. And for trees, we want them to live longer. But I think there's that the idea with the Climate Ready Trees is to help the nursery industry and the public come together to be selecting trees and really paying more attention to the trees we select, but also understanding that it's not as simple as you just move a climate zone, because these polar vortex events are still going to be happening. So it is tricky to plan like that. Yeah. Okay, next question. This is from Edward. for New Mexico, is there a huge chance of losing more aquifers in the coming years?
I guess I would say it's I don't know if I would say losing would be the right way to say it, but I think they're more at risk. Um, we're getting to know more and more about aquifers, and there's different types of aquifers in terms of the recharge and the extent. And but yeah, I think the bottom line is, we're relying more and more every year on the aquifers. With surface water dwindling, we get it, but it's sort of short-lived. I was just looking at the stream flow forecast for the rivers, and they're all short, and then the managers, the decision makers are having to adjust, later irrigation in a lot of them. So, relying, and especially with the lower Rio Grande, with having to mainly pump groundwater out. So, in some of these, yeah, so it's a really tough issue. And there's actually a conference, I think next week or 2 weeks, with the Oglala. We're a little bit into that area, but that is a really big logistical hurdle, and I think we'll learn a lot from how they manage that. So how do we manage some of our smaller aquifers? And I think, and we're learning about how quickly some of these aquifers are recharging. We don't have a lot of data for a lot of these, and so, but we're seeing the impacts of those, with wildfires and burn scars and how things go. But I think I would call them, most of them are at risk, especially with extended drought. I know I had a question about, is this a mega drought? I wouldn't call this a mega drought yet, but it's that, what if that were to happen, where, we're at the beginning of something like that? How should we be managing things now? It's not like we have to stop using it, but it's more of okay, so if that were to happen, what would be the choices that we make in terms of what we plant, and how do we manage to treat it as an impaired, maybe not the word impaired, but a threatened resource. And so I'll leave it at that, because there's many questions of that. We could have a whole conference on aquifers, and maybe that may be a good thing to talk about instead of later on.
Yeah, I did see that Ogallala conference that's next week, but it's the same time as the Land and Water Summit, which is another conference. But thank you very much. Okay, next question from Charles. What fraction of snowmelt at Wolf Creek ski area goes to the Rio Grande drainage?
Wolf Creek. I think that one is in. I would have to double check on that one again. I mainly I have looked at individual SNOTEL measurements, but I think it's a little further. I think it's more. And I may be wrong, but I think it's more influencing the San Juan as opposed to the Rio Grande. I think it's on that cusp over on the as you go out from Silverton, that's sort of the headwaters of the Rio Grande, and then there are a few other stations that are on the ridge line that feed more into the San Juan Animas. But it's all part of the waters of both. But I think so. I would have to double check on that to be sure. But yeah.
And so you mentioned SNOTEL. Do you recommend? Could Charles go to the SNOTEL and find that easily?
I use it. It's real not that easy to do it, but you can actually you could Google SNOTEL data, and there's actually an NRCS webpage that is actually they made it very interactive, and you could put in basins, and then you can put on individual snow telemetry, SNOTEL stations, and then see where the stations line up in terms of the boundary of the basins, and that'll give you the answer. And also you can click on them, and it'll give you the SWE maps. The maps I showed in my presentation, those colored, those are the source of where I got those maps. And you can do them by individual stations, or by the whole basin, and those are the kind of the indicators for how much snow is up there.
Thank you. And that's Snotel is SNOTEL.
Correct.
And that ties into the next question from Camille. Is there a site we can go to that will help us compare current to average weather and rainfall? And then similarly, is there a site we can go to that will allow us to look at the history for a particular date? What do you recommend?
Yes, the answer is yes. There's not just one stop place right this moment.
Mm-hmm.
It may be something we could follow up with. It depends on what area, like the high elevation mountains. The NRCS has a web page that they generate every day, which makes a nice table that you can look at it, and they summarize it by basin. Whereas if you're living in an urban area, that's a different website, and and there's several ways to actually get at that information. And so I guess there's not a quick answer for that. It's more of contact me, and I can send you some links and direct you in the right direction and guide you in how to use the websites. We're getting better in figuring out how to present the data, but we're not quite there in terms of making it really easy. But
Right.
it's better than it used to be 10 years ago.
Thank you. Okay, thank you, Camille. Another question. This is from Clay. When I was a kid, the teacher told us we were going to be going into an ice age. The planet changed a lot over time, hot and cold. And so how do we take that information, and how does that relate to everything we know now?
Yeah. Climate science uses the best information that we have. And so in the 70s, there were some groups, it all depends on the time scales. So let me kind of back out a bit. So if you're a paleontologist, in people who look at really long geomorphology, you're looking at time scales of 1 million years. Yeah, we're actually right now going into a ice age. In terms of it's not like this drop off. It's just like we have these things that are warm periods and cold periods. We're in a warm period, but that in terms of you think about it in terms of millions of years, the time scale, we're sort of at the end of another one and going into a cooling thing. So that's that perspective. And I've got a few papers if anybody's wanting to know. I've saved a bunch of journal articles about that just so that I'm familiar with it. However, I think there was this several groups talking about the interglacials and where we are right now in shorter time period. And I think there was some discussion about are we cooling off? And I think what in terms of to describe that, I think a lot of them we're looking at shorter time periods, looking at shorter. We as climatologists we like to look at 100-year increments. So what has happened in the last 100 years, the previous 100, 300, 400, 500 years. So it's a different way of looking at things. If you look at it in terms of shorter time periods, we can infer things that are trends that may not be the real trends that we're heading into. So there's sort of that how we interpret the climate is what kind of inference we can get out of it. So I have a feeling is when they were promoting the cooling, as we were looking at a shorter time period in the thermometer record, seeing a cooling. And yeah, there were points in time when the temperature was cooling. However, our cooling has stopped, and we since like the 70s, like I showed you in the graph, we've been climbing up in terms of the the indicator of that is our growing season. It's getting longer, and at different rates for different areas. So yeah, there was, if you look in the news from the 70s, 60s, there were some, you can pull up stuff on the internet that talks about the cooling, but we know more about the climate now than we did then. Just like in medicine, we learn, we have data. There's been a lot more measurements. We look at ice cores, we look at cave droppings and sediments and things like that. So we have much more knowledge of what's going on. Climate science is physics and chemistry all been together, and putting it, understanding the Earth cycles and what are the things that we can tweak around that are natural, and what are the things that humans do. And we're learning more about it, and we're building this bigger and bigger. And so we have a better sense of what's going on now than we did back in the 70s. So I'll leave it at that.
Okay, thank you. Okay, and then this one is from Susie. If the weather is getting drier and drought conditions are increasing, why are we seeing more wet weather insects?
Good question.
Yeah. Yeah, I think, well, can go ahead if you'd like.
Well, I would have to look at the source of that wet weather insects. I have, when I did look at the forest health, I did when there were, and I think, I'm not an entomologist, I'm a climatologist. So in terms of the lifespans of the insects, it may be an interplay between, we may have a wet spring and that's their lifetime, but it's overall the whole year is dry. So I'm not sure in terms of you have to look at the context of that insect, which ones and what areas. I don't know the answer to that, but that's sort of
makes sense.
Thinking through it.
Yeah, right. Okay. So in Albuquerque's North Valley, this is Serelda. In Albuquerque's North Valley, there are two other issues affecting trees: mistletoe and bagworm. The prevalence suggests influenced by lower precipitation and higher temperatures. And what do you think?
Well, I don't know that much about bagworms. I know it's widespread, but if there's a very strong climate, indicator that drives their habitats, it's definitely climate driven. But I don't know. It'd be nice to have an entomologist on board here to kind of guide us on that one.
We'll have an entomologist moderator next time.
Yeah.
Well, and we just have 2 minutes left. And so another question came in from Athena. I was surprised to see that Albuquerque is being considered in Zone 9B. I think maybe she's talking about that. Did you say that in your presentation, or was that from the Sarah Hertog's video this morning? I think that's what she's referring to. And my understanding is that it's not that we're in Zone B now, but that is the 30-year model prediction of what Albuquerque might become. And so I think, Athena, that I hadn't read this question before, but so then she goes on to say it definitely gets below 20 here, 20 degrees Fahrenheit. Trees should be on our long-term shade assets to be planted now while the current temperatures can allow for moisture retention. So I think that's what that. Would you agree, just based on the USDA hardiness zones, that Albuquerque's not yet at 9B?
Yeah, I would have to consult a map. I don't know off the top of my head. But yeah, it's as we get more data coming in, we get more accurate maps like that. And we're coming up with a new climate normal, because climate normals are officially the 30-year averages, and we just finished we've been in the 1981 to 2010, and now this coming spring to summer we'll actually have another 30-year chunk of data to use, and that was a warmer 30-year average compared to the 81 to 2010. So it's going to be interesting to compare. So keep that in mind when you look at maps.
Yeah, I know.
It depends on what 30-year average we look at.
Right. So the USDA most recent map is from, I think, 2012, and then but that data is from several decades before that. So then it's like you have to be careful what. That they're not keeping up quite as quickly. Okay. Well, thank you so much, Dr. DuBois. I do have an announcement about the chainsaw, so everybody stay tuned another minute. thank you so much for joining us. We really appreciate your information and the work that you're doing and answering our questions. So thank you very much. Let's see, the announcement I have about the chainsaw is that I'm told that a potential winner has been selected. I asked who it was, but I don't keep secrets very well, and I think Tom knows this, so they said I wasn't allowed to know who it is, but they've been trying to reach this winner by email and haven't heard back. So everybody check your email and see if you've gotten something about being a chosen winner of our chainsaw, and if you have, then write back. Okay, and then I'm also getting a notice that we may be able to post, so some of these questions are so good, we could compile the answer and share them on the ThinkTrees website. And so that's where you went to register at thinktreesnm.org. So at that, thank you. And Andrew, are you on and you want to give us a closing statement for today?
I am. Thank you very much, Marisa. I think everybody got the CEU codes. By the way, Sarah's presentation on climate-ready trees, there's no CEUs attributed to that, but just in case you were wondering. But I just want to say, it's another great day, and I want to thank you all for attending and your willingness to learn and grow in your profession. Frankly, by your attendance today, our communities benefit, and hopefully the value you bring to your customers, your clients, and your entities will be acknowledged. Again, visit each of the sponsors that you see. Click on their logos and visit with them. A lot of those folks are attendees. Chat with your fellow attendees, and you can do that after we sign off today. And I just want to say, enjoy your afternoon. Thanks again. We'll see you all tomorrow, same time, same station. Ciao.